And also, too, guys, you'll notice that if you're working with the right formula, guess what will happen? Your units will actually come out to be the correct thing, okay? So you've got, this is your formula right here, okay? And you're going to use this formula to plug in the numbers. What you also want to make sure that you have in mind are the correct units, and they need to be in the proper format. And I'm going to share with you what I mean by that. So for instance, you see up here where your delta H, right? It's in kilojoules per mole. But then when you look at your delta S, it's in joules. You'll want to make sure that your kilojoules is in joules in order for you to get this answer correct. Because if not, one of these answers on here is going to be for you by not putting it in the correct format. So when you read through your examples, make sure that your units are the same. It says a reaction has a delta H of negative 35.4 kilojoules per mole, and delta S is equal to negative 85.5 joules per mole dot Kelvin. At what temperature will this reaction be at the equilibrium delta G equals 0? So in a case like this, they're telling you that your delta G is equal to 0, which means you're going to, in essence, solve for your temperature, okay? So if I put the 0 there, substitute the 0 in, just like this right here, I, in essence, will switch everything over to the other side so that we can have our T by itself. So for instance, if I move the delta H off to the other side, you know what? No, I'm going to keep the delta H over here, okay? I'm going to move the T delta S to the other side. That cancels out, and you end up with T. And look, I had a negative plus a positive to cancel that out. So this is just going to be T delta S equals delta H, right? Well, here's the thing, and you can actually take that little degree sign off, for this particular problem. But what you're going to do, because you're looking for your temperature, you're going to now divide both sides by the delta S so that your formula now is T equals delta H divided by delta S, okay? In chemistry, you have to learn to derive your formulas when you are solving for your unknowns. If you can derive your formulas, this is very helpful, okay? This is your standard formula right here, but they set the delta G to be equal to 0. Therefore, your final formula, after you go through and do the derivations, you're going to look for your temperature. Yes. So your T is equal to delta H divided by delta S. Now, here's something else you need to do. Your kilojoules up here needs to be converted to a joule. That means you need to multiply that times 1,000. All right. So that's the other thing that we need to do in this particular problem. Okay, so I'm going to go back up here and I'm going to put this off to the side, that 35, okay, that negative 35.4 kilojoules. We need to get it into a joule, all right? We need to get it into a joule. So we're going to multiply it times 1,000 because 1,000 joules, okay, is equal to 1 kilojoule. So that's going to equal to, so if we plug this into our calculator, all right, that's going to be equal to 35,400 joules. Now, I put that there because I want to make sure that I have that already in place when we do our actual problem right here, okay? So let me scoot this back on up so we can have some space. So we can have some space right here. All right, now I'm going to erase the board so that we can go ahead and apply the numbers that we need for our problem, okay? So I'm going to erase this part right here, and we're going to use the numbers, and this is our formula that we're going to use right here. Okay? This is the formula. T for the temperature is equal to the delta H divided by delta S. Our delta H, okay, up here was the negative 35.4 kilojoules, but remember, we just converted it, so that's negative 35,400 joules per mole divided by negative 85.5 joules per mole dot Kelvin. Now, right here, guys, you should notice that your joules per mole are going to be what? Crossed out. They're going to be canceled out because we don't need them anymore. So therefore, you're finding your kelvins, okay? See that? You end up with your Kelvin as being your temperature. So say 35,400 divided by 85.5, and you get 414 Kelvin. All right? 414 Kelvin, letter A. But look, letter C is on here too. If you did not convert your kilojoules to a joule, then you would see how letter C is on there as well. So this is what you guys got to keep in mind, okay? You make sure that the units are the same. Units are the same. All right? So in this particular example right here, okay, in order to find the temperature, you have to have your delta H divided by your delta S. The delta H was kilojoules per mole, but your delta S was joules per mole dot Kelvin. I cannot cancel kilojoules with joules. I have to convert kilojoules to a joule in order for this to work, and that's what we did previously. Number five.